Hi folks, we're going to take a look at number 4 from page 564. So here they're asking at what point is the tangent to the curve x plus y squared equals 1 parallel to the line x plus 2y. All right, so the tangent, of course, is a line, and this is a line. So two lines are parallel when their slopes are the same. So let's start by finding the slope of this line. So here, 2y is equal to negative x, so y is equal to negative 1/2 x, and so the slope of that line is negative 1/2. All right, so this tangent has to have a slope of negative 1/2, and of course, the way we find the slope to a tangent is to take the derivative of the function, or in this case here, possibly a relation. Okay, so since isolating y would mean having to take a square root and possibly a positive or negative square root, it's much simpler to just differentiate this implicitly. Okay, so we do that by taking the derivative with respect to x of both sides. So derivative of x with respect to x, of course, is just 1 plus, and to take the derivative of y squared with respect to x, we have to use the chain rule. So first we take the derivative of y squared with respect to y, so it's 2y, and then we multiply that by the derivative of y with respect to x, which I'll represent by y prime. All right, and then here, derivative of 1 is equal to 0. Okay, so now we'll solve for the derivative of y with respect to x. So y prime is equal to, so I'll bring the 1 to the other side, negative 1, and then divided by 2y. Okay, so this is the expression that gives the derivative of y with respect to x, in other words, the slopes of the tangents. So we need to equate this to the slope that we're interested in, which is negative 1/2. All right, so we do a little solving here. So, we got negative 2 equals negative 2y. Divide both sides by negative 2, so y is equal to 1. All right, but what they asked for is at what point is the tangent horizontal to this line, and so all we found here was the y value. Now we have to determine the x value, and to do that, we're just going to input that back into the equation. So wherever I see y, I'm going to input that. I'm going to put 1 instead, and so here it turns out that x is going to be equal to 0. So the answer, at what point will the slope of the tangent at what point will this tangent line to the curve be parallel to this line? At the point 0, 1. All right, so just to recap, here we two objects need to be parallel. These two objects are lines, hence their slopes have to be the same. The slope to the line is just easy to find. Put it in slope-intercept form. And of course, the slope of the tangent to a curve is given by the derivative. And so it was just a matter of equating those two and then solving for the particular point. All right, that's it for this one.